All right. Chapter 1, we're talking about functions and their graphs. Now, you probably remembered some of this from previous classes, but we'll try to go through it fairly quickly then. So, the first thing I'm going to ask you to do is plot the ordered pairs 3, 1 and negative 2, 3 on the Cartesian plane. It's a fancy name there. So, we have 3, 1. So, we're going to go 3 to the right, 1 up, and that's the point 3, 1. And then we'll do negative 2, 3. So, we'll go 2 to the left, 3 up. And it says label each point as x1, y1, pardon me, and x2, y2 respectively. That means respectively means in the same order. So the first point that we listed, the 3, 1, we're going to label that as x1 to x1, comma, y1. And then the second coordinate we'll label as x2, comma, y2. We're going to use these 2 points and we're going to make a triangle out of it. Now, the easiest way to make a triangle out of it is to draw a line segment, a straight line segment. Straight line is redundant, but that's irrelevant right now. But we'll create a line segment between those two. And then we're going to form a right triangle by dropping a horizontal line down from that upper left point and then dropping a vertical line. Guys, this is the first time I've had to teach in like 5 months. Please forgive me. But we'll drop a vertical line from that left point, and then we'll draw a horizontal line to that right point. So now we have a right triangle. And then think about some things we've done with the right triangles in the past. Let's label some things. You might remember these letters A, B, and C. We labeled the two, we call them the legs of the right triangle, the two sides that form the right angle. They're also the two shortest sides. We'll label them as A and B. Technically, it's not a big deal about which one we label as which, but we're just going to leave them as this. And then the hypotenuse is going to be our point C. Now, the Pythagorean Theorem, you may recall, is A, B, and C. I kind of jumped ahead. The Pythagorean Theorem you might recall as A squared plus B squared equals C squared. Sometimes you hear it written the other way where C squared equals A squared plus B squared, or you can flip the A squared and the B squared. It doesn't really matter. Now, we're asked to write the Pythagorean theorem replacing a and b with x1 and y1 and x2, y2 values. Well, let's go back to the graph. So, ignoring those specific points, the coordinates of 3, 1 and negative 2, 3, we're just going to deal with the x1s, y1s, x2, y2s. Now, let's talk about this segment A here. Segment A, we need to figure out how long it is. We need to figure out what is the length there. Now, looking at this, because we know the specific coordinates, we can see it's 2, because it goes up from 1 up to 3. But how else could we do that? One way we can do that is by taking y2 minus y1. Now, just because we're talking distance and we always want to make sure it's positive, like in this case, y2 minus y1, it'd be 3 minus 1 giving us 2. But technically, you could flip it around and do y1 minus y2. But just in case things get crazy, let's just put it in the absolute value. We're going to say it's an absolute value because it's a distance. Remember, absolute values means a distance from 0. It means that you're always going to get a non-negative answer. Sometimes it'll be positive, could be 0, but it's never going to be negative. The b value, using the same type of information here, this length here, from over here to over here, it's not my best squiggly, but please forgive me. It's going to take, there we go. It just took a second to get on screen. Now, we can clearly see we could do this coordinate. So from negative 2 all the way over to 3, we could count and go 1, 2, 3, 4, 5. Or what we could do is x2 minus x1. Now, if we're to do that with our current coordinates, you'd have negative 2 minus 3, and you'd get negative 5. This is what I was saying earlier. In order to make it a distance, we're going to put in an absolute value every time. Okay, so now we can replace a with y2 minus y1, or in this case, the absolute value, and we can replace b with x2 minus x1, or the absolute value of it. So, going back down here, let's zoom to that part. So we're going to replace a with y2 minus y1, and we're going to square that. Now, when we square any value, it's going to become a non-negative answer. So at this point, I'm kind of going back on what I said earlier. At this point, we can kind of ignore the absolute value because whenever you square something, it's not going to be a negative output. You're going to get a positive output. And then plus our b value we said was x2 minus x1. And again, we can ignore the square or the absolute values because when we square, we're going to get a positive output anyways. Equals c squared. Now, we can keep going with this a little bit because we're trying to come up with this thing called the distance formula. So we're looking for the distance between those 2 points. Just to highlight that, sorry, I got a dog barking in the house. We got this distance here we're trying to figure out, and that's that length c. Right now, c is being squared. Now, in order to get rid of that square, what do we got to do? We got to square root it. So we're going to square root this side, and we're also going to square root that left side. So we're going to end up with just c, and when we square root this side, it doesn't really change. I mean, we can't really simplify this. We can't simplify each individual piece, so we're just going to have to leave it, and I'm going to put it in a more standard form that you might be used to. Because remember, you could put a squared first or b squared first. That means we could put the x2 minus x1 first, or the y2 minus y1. But just because this is more similar to what we've seen, we got x2 minus x1 squared plus y2 minus y1 squared. And that, folks, you might remember is the distance formula. So we have this d distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Remember that whole thing, and I didn't do it very good. There we go. That whole thing is underneath the square root. Last thing we're going to talk about on this page is the midpoint formula. The midpoint formula, it's the midpoint of a line is halfway between 2 points. So looking at this here, the halfway between 2 points is just eyeballing. It's like right about there. I'm cheating because I didn't show up there. There we go. I know exactly where it is. Well, in fact, I know exactly where it is, and I still drew it a little poorly. The midpoint is probably right about there. Now, in order for us to calculate that, what we're going to end up doing is use the midpoint formula, which is, I'm going to call midpoint MP, very creative name. Let me shift or zoom in so my face isn't covering it. We're going to say is x1 plus x2 divided by 2. So we're going to add the 2 coordinates together and divide it by 2. The y coordinate is going to be y1 plus y2 divided by 2. It's the halfway. So we're kind of like taking the average of each of the coordinates. Now again, as I was kind of saying earlier, in this case it doesn't matter if you flip the x1 and x2 around because you're adding. Adding is commutative. You can flip the numbers around. Subtraction is not, but adding is commutative. So we could do x2 plus x1, doesn't make a difference. All right, on the next page, we're going to practice a couple of these. This first one, it says find the distance between the following 2 points and also the midpoint of the line segment that connects those 2 points. So in this case, we should probably go through and just label the coordinates. So just because it's the first point we have listed here, let's call it, sorry, I didn't realize my mouse was there the entire time. Yikes. Not going to remake the video for that. But anyways, let's label these coordinates. We'll label them as x1, y1, and we'll call this one x2, y2. Now we're going to plug them into the distance formula. Let me write that back up at the top, and if you want to again write it, we got d distance equals square root of x2 minus x1 squared plus y2 minus y1 squared. All that underneath the square root. Okay, so plugging in what we know, we got d equals the square root of our x2 value that we have here is -5 minus x1. In this case, our x1 we decided was 2. And we're going to square that, plus y2 was 7, minus our y1 of 4, and we're going to square that. Taking this piece by piece, we got distance still equal to square root of -5 minus 2. That's going to give us a grand total of -7. That's still got to be in parentheses, and that's going to be squared. Plus 7 minus 4, that's 3, and we're going to square that. D equals, taking it piece by piece. Remember, we're still working with the order of operations. So, you remember PEMDAS? Sometimes we talk about parentheses. We just dealt with the parentheses, but really we shouldn't use parentheses. We should say grouping, because parentheses are a type of grouping symbol, and so are square roots. So that means we got to do everything underneath the square root first and simplify that all first before we can even begin to take the square root. So let's take care of what's inside. So underneath that square root, we got to take care of those exponents. -7 squared is -7 times -7, which gives us a grand total of +49. Remember, anytime you square a value, it should end up with a positive output. You might find some contradictions later, and I'll tell you why those aren't really contradictions. But that's besides the point. 3 squared, 9. Let's add those together. We got d equals the square root of 49 plus 9 is 58. Now, you're looking at this, we got it down to a single number, 58. 58, unfortunately, not a square number. Now, when we get to a point where we have a number underneath a square root that's not a square number, what we can try to do is break it up. It's called simplifying the radical, or reducing the radical, sometimes you hear it as. Now, in order to do so, we got to break it up. Think about numbers that multiply together to give us 58. Ideally, we want to come up with one of those factor pairs to be a square number. So let me think. There's not a whole lot of factors of 58. That's kind of unfortunate. So the only factors I can think of, if there are others, my mistake, but it's 2 and 29. Now, 2 times 29 is 58, so the square root of 2 times the square root of 29 is the square root of 58. This doesn't really help us. We tried, didn't work. Unfortunately, there are no other options, so we can actually pretend that didn't happen. We're just going to say d equals the square root of 58. That's as exact as we're going to be able to get it. For our midpoint, we're going to use that same formula. Let me write that formula back up at the top here in case you don't have it memorized from the previous page. We got MP equals x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. All right, let's try this out. We got x1 we said was 2 plus x2, negative 5. Divide that by 2. And then our y values, we're going to have 4, our y1 plus 7 divided by 2. Now, 2 plus negative 5 is negative 3 divided by 2. That's kind of gross, but whatever. 4 plus 7 is 11 divided by 2. Folks, I'm perfectly okay with us leaving it like this. Negative 3 over 2 and 11 over 2. Those are perfectly acceptable answers. If you want to reduce it to a decimal, because these decimals are kind of nice, you'd end up with negative, skip my negative, negative 1.5, comma, 5.5. Those decimals are not bad. That's fine. Ideally, we'll probably leave them as fractions, especially because sometimes you'll get fractions that have not so nice denominators. To pause the video, take a few moments, and then see if you can get letter B. Alrighty, for time's sake, I'm not going to show you all the work, but I want you to check your answer and compare it to mine. I got D equals the square root of 232. If you didn't go back, or didn't get that, go back and make sure you plug it in. Make sure, again, that you're labeling x1 and x2. So maybe this will be x1, sorry, I forgot the 1. x1, y1, and this one would be x2, y2. Make sure when you're squaring things that if something's negative, after you square it, you end up with a positive. Yeah, everything underneath the square root should be positive. Now, even if you got to this point, you're actually not quite done. Because as I said in that first example on letter A, remember, you got to try to break things up. For example, 232, not a square number. Okay, so let's try to break it up. Now, if you don't know of values that work, like 232, I don't know all the factors of 232. What I'm going to just try to do is take square numbers and divide 232 by that number. So for example, 232, I'm going to go with the lowest square number of 1. Just kidding, we're not going to divide by 1. You get the same number. The second lowest square number is 4. Now, this conveniently does break up. 232 divided by 4 is 58. Folks, you're not expected to know that. Just try numbers. Try dividing it by 4, 9, 16, 25. If it doesn't divide by any of those, okay, maybe go to 36. Just try a good number of them, and then if at some point you're running out of numbers, like if you're dividing by 625 to see if it's a you're too far. So we got 4 times the square root of 58. Now the reason we break it up, square root of 4 times the square root of 58. The reason we break it up is now we can reduce that part a little bit. Square root of 4 is 2. And the square root of 58 is, well, we just ended up with that in the previous problem. The square root of 58. Call that good. Midpoint. The midpoint you should get on this one, 2, 0. If you did not get that, sorry, let me shift this over so you can actually see what I just wrote. If you didn't get that, double check your work. Make sure you're adding the x values together and dividing it by 2, and then adding the y values together and dividing by 2. Pause the video right now, give letter C a shot, come back, check out your answers, and you're back and you clearly paused and you're not just continuing to watch the video. This one, after you go through all the work, please show your work. For time's sake, I'm not going to. We got D equals the square root of 53. That's not reducible. 53 is actually a prime number, if I recall correctly. And then the midpoint, you end up with 5 comma, I believe 3.5. Or you could say 7 over 2, 3.5. Either way works for me. And that's all.